Welcome back. We're now going to turn our attention to a very important concept in thermochemistry called enthalpy. And enthalpy has a strange name, and for that reason lots of people think it's hard. But it's essentially the heat that's stored in the bonds in a chemical molecule. And when bonds break and new bonds form in a chemical reaction, you have a difference in heat. So you're going to see that in many reactions, you're either going to have a release of heat or you're going to have an absorption of heat. If you had more heat stored in the bonds at the beginning than at the end, then it's released. If you have more stored in the end than you do at the beginning, then it's absorbed. So we're going to look at how this works. So first of all, we have to know that this only works when it's an open air. So if you're working with beakers or test tubes or something to where that there's air pressure involved, then the only thing that enthalpy includes is the heat content. It deals with pressure and stuff if you have closed containers. But as long as you have open containers, the only thing enthalpy involves is the heat that comes into a system or out of the system. So let's define our terms. The amount of heat stored in the bonds of the reactants is called the enthalpy of reactants, otherwise called the heat of reactants, and there's a capital H to stand for that. So H sub R is the heat content of all the reactants at the beginning of a chemical reaction. The amount of energy stored in the bonds of the products we'll call the enthalpy of the products, or the heat of the products. So the heat content and enthalpy can be interchanged terms. So here's something very obvious, and we've already explained this, that if you have more heat stored in the bonds at the end than you do at the beginning, and you subtract the products from the reactants, you're going to get a positive number. So the change in enthalpy, that's what the delta H is, the change in enthalpy will be positive. So if the heat content of the products is lower than the heat content of the reactants, so that means that you had more at the beginning and less at the end, then that heat had to go somewhere, so it escaped, and then the change in enthalpy would be negative. So you're going to see that if it gets hot at the end of a reaction, you're going to have a negative enthalpy. So your delta H will be negative. If it gets cold at the end of a reaction, you're going to have a positive change in enthalpy, or delta H. So this change in enthalpy, we're going to call it delta H, is simply going to be the enthalpy of the products minus the enthalpy of the reactants. And it's essentially the amount of heat that's lost or gained by a system. So let's look at some specific terms. If it gets hot at the end, you're going to have what's called an exothermic. Exo means out of, and thermic is heat. So you're going to lose heat. That means that your energy stored in the bonds are going to be less at the end, and so that heat that was stored at the beginning has to go somewhere, and it goes out of the reaction, so it's going to get hot. So we know that the delta H is negative, and heat is actually considered one of the products of that kind of a reaction. Here's an example. This is methane gas that is going to be burned in air to give you carbon dioxide and water, and then heat is considered one of the reactants. So it gets hot, and you know this because this is what you burn gas for. If you heat your house with gas, you're burning methane gas for the heat content of that gas. So it's considered one of the products. The opposite term from exothermic is endothermic. And endothermic, endo means into, and thermic means heat. So that means that you're actually going to take energy from the environment, from the surroundings, and put it into the system. So you are going to have heat as one of the reactants, and therefore delta H is positive. Here's an example. If you take chalk, calcium oxide is chalk, and you simply heat that chalk, it'll eventually break down. It's called thermal decomposition. It's going to have a decomposition reaction, and it's just broken down. That heat does it, and so you're going to have that heat goes into the bonds. So that means you have more bond energy in the products than you do at the reactions, and so therefore delta H is 0.